So this section is going to talk about the relationship between tangents and secants and chords and their segment lengths. So first of all, we need to establish a couple definitions. A tangent segment is a segment that is tangent. So we talked about tangent lines before, but PS here is what we would consider a tangent segment. A secant segment, same thing, is a segment that is a secant. So PQR is a secant segment there. So it acts the same way as a secant or as a tangent, but these are just segments, not whole lines. So we're going to go through a couple theorems today. This is our first one. If we have two secants that share the same endpoint, then the product of one segment and the length of its external equals the product of the other and the length of its external. So let's boil that down. So these are our secant segments. BF is that whole segment, and DF is that whole segment. Now I'm going to highlight the outside part. So CE is the outside part of that, CF. EF is the outside part of that. So here's what this theorem says. It says that if I take one of those tangents and I do the whole length times the part that's outside, that will be the same as the other segment if I take the whole length times the part that's outside. So this would really be the key to remembering this. Whole times outside equals whole times outside. So let's see how this works. So if I look at an example like this, I want to find x rounded to the nearest tenth. I see that these are two secants and they share a common exterior point. So their whole length would be this length and that length. Their outside length would be this part and this part. So I'm going to do TV, and then I'm going to do this same thing for XV. So for TV, the whole length is 7 here plus 4 there. So this is 11 times the outside part, which is 4. And that needs to equal the same as the other side. So whole times outside. The outside part here is pretty easy to tell. That's just 5. That's this part here. This whole length, just like here we did 7 plus 4, here we need to do A plus 5. So my whole length here is A plus 5. So now I'm going to distribute out on one side and just multiply on the other. 5A plus 25. Subtract 25 over, so I get 19 equals 5A. And so I get A equals 3.8. So now let's look at the next one. So this one's really similar. Last time we had two secants. Here we have a tangent and a secant. So for the secant, nothing changes. It's still the whole length times the outside part. But for a tangent, that gets a little bit trickier because the whole length of the tangent is B to D. And the outside part is also B to D. So notice that those are the same length, right? So here's our formula for when we have a secant and a tangent. It's still whole times outside for the secant, but the tangent is going to be the tangent times itself, or the tangent squared, because the whole and the outside are exactly the same for the tangent. So let's look at an example of this one. So we want to find the value of x. So let's do some highlighting here. So for the secant, this is my whole. This is the outside. For my tangent, x is the whole, and x is also the outside. So it's the same thing there. So for the secant, I would do 14 plus 8, so 22, times the outside, which is 8, equals x times itself, or x squared. So 22 times 8 is 176. That equals x squared. And now I'm going to square root both sides. So x equals 13.3 to the nearest tenth. So now let's go to our last theorem, and that's this one. What if we have two chords intersecting in a circle? So what this says is the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of another chord. So it says that EA times EB would equal CE times ED, which is going to multiply parts. So I think about this one like part times part equals part times part. So let's look at this example. So divers near the Greek Isle discovered several fragments of ancient items. Using mathematics, they were able to calculate the diameters of disks. So suppose the length of AB was 12. So right now I see that AB, this part's labeled 6. So I'm also going to label this part 6 because I know the whole thing's 12. What is the length of PR? So we already know PQ is 3. I'm going to use a different color for this actually. And so now I want the length of QR. That's going to be my unknown here. And we can add those together to get the answer. So for AB and for PR, I'm going to do the same thing. I'm going to do part times part equals part times part. So this is 36. This is 3x. And so x equals 12. So here I get that this part is 12. So what they wanted to know was what was the length of PR. So PR is 3 that we already knew plus that 12. So it was 15 inches.